Good morning, class. Today we are going on to chapter 8 and section 8.1, length of arc. Okay, I'm going to introduce to you some terms that we usually use in a circle problem. Okay, now this is a circle and this is a line that touches the circumference here. Now this line PQ is called the chord. C-H-O-R-D, a chord. Now, in fact, a chord can be any line that is drawn from circumference to circumference. All these red lines are also called chords. Okay, so chords are just straight line that touch circumference to circumference. Alright, now a diameter will pass through the center. Okay, and it's called the diameter, it is not called a chord. Okay, a chord is any other line that touches the circumference to circumference. Okay, now what is a minor arc? Now, a minor arc is an arc here that is PRQ. Okay, it is less than half the circle. Okay, now what about a major arc? The major arc will be the arc, this whole thing, the red one, PSR. This will be called the major arc. Now, why is it that the minor arc is being called PRQ and the major arc is being called PSQ? Now, we need three letters to identify an arc because we have to know whether is it the minor arc PRQ or the major arc PSQ. If you just call the arc PQ, we do not know whether is it the minor or the major. Okay, because there are only two endpoints and we can go in this direction and this direction. So usually for an arc, we will use three letters to represent the arc. And make sure you know that the minor arc is less than half the circle and the major arc is more than half the circle. Okay, next we are going on to sector. Now, a sector is part of the circle. It's a form like the way you cut a pizza. Okay, this is called a sector. Now, I'm going to shape this. This is a sector. Okay, sector is a part of the circle. Now, what do you mean by a minor sector? A minor sector will be less than half the circle, and the major sector will be this one. This will be the major sector, whereby it is more than half the circle. So a sector is part of the circle and a minor one is less than half, a major one is more than half the circle. Okay, so you must know what we mean by sector and what we mean by arc. Okay, and what is a minor arc, major arc, what is a minor sector and major sector, and what are chords. Chords are just lines here. All these are chords. Okay, alright, now next I'm going on to what we mean by a segment. Okay, now a segment is just this part here. It is surrounded by the circumference and a chord. Now this one, the green one, is called a minor segment because it's less than half the circle, and the red one will be called the major segment because it's more than half a circle. Okay, now make sure you know the difference between sector and segment. They mean different things altogether. A sector is surrounded by the arc and the radii. A segment is surrounded by the chord and the arc here, the circumference. Okay, so a sector is part of the circle that's surrounded by the radii and the circumference, while the segment is surrounded by a chord and part of the circumference here. Okay, so just bear in mind that minor means less than half the circle, major means more than half the circle. So these are the basic terms that we need to know for length of an arc in the segment of length of the arc. Okay, now I'm moving on to the formula that is given on page 248. Now this is quite intuitive, and I believe all of you can understand what it means here. Now it gives you the formula here. The length of arc is actually x degrees over 360 degrees times circumference. Now we know that circumference is 2 pi r. So if this angle is x degrees, this angle here is x degrees, we will take it is proportional. Is the whole thing is 360. So x over 360 times 2 pi r. Now actually we can get this from here. Everybody agrees that x degrees over 360 degrees will be the arc ARB over the circumference. This is by proportion. This is the angle, this is the arc, okay? The whole circle is 360 degrees and the whole circle here is the circumference. So we bring to the other side. Sorry, I'm just going to do this. ARB will be equals to x degrees over 360 degrees times circumference. So it's this particular formula is actually this one that is given on page 248. And there's another term that I want you to take note of. Now, if this is the arc that we are referring to, the arc ARB, okay, this will be the angle that is subtended at the center by the arc ARB. Is the word called subtends. So this arc subtends this angle, okay? Now, next, I'm going to show you a very easy proof. We know that this is a quadrant, this is 90 degrees, okay? This part here is 90 degrees. And we know that this is the arc that subtends this 90 degrees. So we know that actually this arc is 1/4 times 2 pi r, which is the circumference. Now how do we get this 1/4? It's actually 90 degrees over 360 degrees, which will give us 1/4. Okay, that is a quadrant. Alright, now if we have this semicircle here, what is the length of this? The circumference of this semicircle? It will be half times 2 pi r. Now how do we get this half? It's actually 180 over 360 degrees, which will give you half. Okay, so it is quite clear that if the angle is larger, the arc will be longer. Okay, if the angle is smaller, the arc will be shorter. Okay, now let me just bring up this point again. If I have a circle, okay, and I have an angle here, this is the angle that I'm going to shape for you. Okay, where is the arc that subtends this angle? It will be this arc here, the whole thing here. Okay, so this arc subtends, this arc subtends this angle, whereas this arc will subtend this angle. So we must know what we mean by the word subtends. Subtends means the angle at the center that is proportional to the arc that is on the circumference. Okay, and one more thing to caution you is an arc means that it's part of the circumference. Okay, arc means just a line. Okay, so that's why we call the length of the arc. Alright, arc means part of the circumference. Okay, now I'm moving on to example 1 that is found on page 249. Okay, page 249. So let us take a look at page 249, work example 1. Now the question says to find the length of the minor arc AXB. Now the minor arc is actually here, AXB, and we are told that this is 124 degrees. So we apply the length of arc formula, 124 over 360 times 2 times pi times 12, and we'll get the answer to 3 significant figure. Now if the question do not give you the value for pi, you will use the pi value from the calculator. Now, next one is important because they say they want to find the perimeter of the major sector OAYB. Now, OAYB is here. You want the perimeter of this sector. Now, you must know that the perimeter of this sector consists of this major arc here, plus you must add these two radius. Okay, then it's the perimeter. Many students will just find the length of the arc and forget about the radius, and that is wrong. Okay, now, in order to find the length of this major arc, I need to find this angle. And this angle is given by 360 minus 124 because it's angle at a point. So this, it will be a 236 degrees when we use 360 degrees minus 124. So this portion here will give you the length of the arc. Then you must plus these two radius. So I plus 12 plus 12. I will get the final answer rounded off to 3 significant figure as 73.4 cm. So that's how we get our work example 1. Okay, now another thing that I need to tell you about this formula is that this formula, we can use it to find length of arc. We can also use to find the angle subtended at the center. We can also use it to find the radius. That means we can use it to find length of arc, the angle, or the radius. Now, these three, given any two, we can find the third one. All these will be illustrated in the exercises and the examples that we are going to do later on. Okay, so I repeat, this formula can enable us to find length of arc or angle or radius. Given any two of them, I can find the third one. Okay, so that will be how we apply the formula here. Now, I want to tell you something about how we set questions and how we should know how to read the questions. Now, if you are given a circle and the question just say angle AOB, it will just mean this angle here. Okay, angle AOB will just mean this angle here. Now, if the question say that they want reflex angle AOB, then it will be the other one. Okay, reflex angle. We must know that a reflex angle is more than 180 but less than 360 degrees. Okay, so that is called a reflex angle. So if a question say angle AOB, it will just mean this angle. When they say reflex angle AOB, it will be the reflex angle. So it will be very clear in the question whether we want this or we want this. So please bear this in mind. Okay, now I want you all now to look at practice now. I'm going to go through one question, and that is question number 3 of practice 1 now. Okay, question number 3. Now, this question asks you to find radius, and they tell you the length of the major arc is 36 cm. Now, everybody knows that major arc means this arc here. Okay, if it's this arc here, I need to find this angle. So I'll find this angle is 310. So 310 over 360 times 2 times pi times r will give me 36, because they tell you that it's 36 cm. So you bring everything over except the r. So you have 36 divided by this, divided by 2, divided by pi, you will get a 6.65. The question asks you to find the value of r, so this is to find the value of r. Okay, so can you see that we are using the formula to find the radius of the circle? Okay, alright. And one more thing to bear in mind is be careful when you read the question whether they are referring to the major or the minor arc. Okay, be very careful because the angles will be different. Okay, now we go on to example 2. Now let's look at example 2. Example 2 wants us to find the perimeter of the shaded region ABC. Okay, the perimeter of the shaded region ABC. Now, that means I got to find this length, the AC, the length of CB, and the length of AB. Then I can get the perimeter of the shaded region. Now, this is 45 degrees angle. You will follow that by angle sum of triangle. This angle here will also be 45 degrees. Now, since both are 45, this is an isosceles triangle. Therefore, this side will also be 8 meters. So, angle ABO is 45 degrees. Angle sum of triangle. So, it will conclude that triangle OAB is an isosceles triangle, which will mean that AB is also 8 meters. Now, you will ask me, what if I cannot see that it's an isosceles triangle? So how would I find out AB? Alright, what if you cannot see this an isosceles triangle? Don't forget, we can use, for a right angled triangle, we can use Tuakaso. So if you see that you want to find out AB and you know OA, so tangent 45 degrees will be equals to AB over 8. So AB will be 8 times tangent 45 degrees. So if you press the calculator, this will still give you 8 meters. So you can use sine, cosine, tangent when it's a right angled triangle to find the length. Okay, so we have found that AB is 8 meters. Now the problem is we now need to find the length CB. Now we know that OC is the radius and is 8 meters. So I will have to find this OB here. Now I use cosine. Cosine 45 is 8 over OB. So OB is 8 over cosine 45 degrees. And I will have 11.313. So the length of CB will be 11.313 minus 8. I'll get 3.313. Okay, so I found this length AB and I found this little length CB. Now is the time to find this arc AC. Okay, now one more thing is that in order to find OB, an alternative method is to use Pythagoras theorem. You can also find OB. Okay, alright, next I'm going to find out the length of AC. I use 45 over 360 times 2 times pi times r. I get this value. And to find the perimeter, I just add these 3 up. I will get 17.6 meters as the final answer to the perimeter. Okay, now some students will ask me, I put degrees here. Is it okay if I don't put degrees? The answer is yes, because they are just ratio. You can don't put these degrees and don't put these degrees. The answer is still okay. And the presentation will be marked as correct because it is just a ratio. When we take a ratio, we must ensure that the units are the same. Okay, so that will be your work example 2. Alright, next I'm going on to work example 3 that is found on page 252. Okay, now the question states that first of all you have to find the length of AB. The length of AB. Okay, now I'm going to show you this. All of you look at this triangle. It's actually an isosceles triangle. Okay, now if I draw a perpendicular, that means this one, the question will tell you is 59. So I can actually find the length of PB. Now one thing about an isosceles triangle is that if it's an isosceles triangle, if you drop a perpendicular down, these two will be the same and these two angles will be the same. Okay, so this is a property of an isosceles triangle. So if I look at this green isosceles triangle, what I will have is that this is 17 and this is 17 because it's the radius. Okay, 59, 59. Okay, now I'm going to find PB. When I find PB and I times 2, I'll be able to get AB. So I use sine. Okay, sine 59 is PB over 17. I'll get PB as this. So AB will be 2 times of this. I'll get 29.1 cm. So that's how I find out what is my AB. Okay, now next question asks you to find the perimeter of the shaded region. Now where is the shaded region? The shaded region is this one. In order to find this perimeter, I must get this arc ARB and this arc AQB and add them together, that will give you the perimeter of this region here. Okay, now first of all, we know that this is 59, 59, 2 times, so we take 59 times 2 to find the angle subtended at the center. So I'm going to find the outer one first. Okay, the outer arc ARB first. Sorry, AQB first. Let's find the inner one first. AQB, this arc. Okay, now I know that, okay, length of arc AQB will be angle over 360 times 2 times pi times r. The r here is 17 because this is the radius. Okay, so I will get this particular answer. Alright, I will get this particular answer. Now, let's look at the outer arc, the ARB, the big one. Okay, now don't forget, the question says that ARB is actually a semicircle with AB as the diameter. Okay, if AB is the diameter, that means the radius will be half of AB. Alright, okay, now let's take a look at this. Length of arc ARB, this is ARB. Now, don't forget this is the arc, and we have half because it's a semicircle. Half times 2 pi r. Now, r of this semicircle is actually PB here. Okay, that's why I substitute this in. This is the length of PB, which is the radius of ARB, the semicircle of ARB. So I will get this answer, and when I add these two answers up, I will get the perimeter of the shaded region as required by the question. Okay, now one thing to take note is that 17 cm is the radius of the small arc, whereas PB is the radius of the semicircle here. We must know what radius to take and read the question carefully before we can solve the question. Okay, so that will be your example 3. Alright, now the following will be done, and you have to do this as your homework. Okay, alright, you have to do this as your homework. Okay, now let's take a look here. In the notebook, can you please do exercise 8A, question number 9, and on the foolscap 2B, 2C, 3A, 4D, 6, 7B, 8, 10 and 12. Okay, you may pause the video if you need to take down the numbers. Okay, now in the next section, I'm going to go through the questions that I have set in the notebook as well as on the foolscap paper. Okay, now I'm going to go through the notebook work first. Alright, the notebook work first. Okay, now let us take a look at the notebook work. That is question number 9 of your notebook. Okay, so let us take a look now. Alright, question number 9, page 254. Page 254. Now the question says that in the figure, the length of the minor arc is 7/24 of the circumference of the circle. That means the length of this arc is 7/24 of the circle, of the circumference of the circle. Find angle AOB. Now I want you to know that angle over 360 degrees will be 7/24. Okay, many people will miss this out and they'll be wondering how to get the answer. That's why I want you to do this in the notebook. Can you see that this angle over the whole thing is proportional to this arc over the whole thing? So it's 7/24. So we can find our angle AOB this way, and it will give us 105 degrees. Alright, part 2. Given that the diameter of the circle is 14 cm, find the length of the minor arc. Now, bear in mind, if the diameter is 14, the radius is 7 cm. Always be very careful when you read the question whether they are referring to the diameter or the radius. So, length of minor arc will be 7 over 24 times 2 pi r. You'll get 12.8. Now, some students will ask me, can I take 105 over 360? The answer is yes. When you take 105 over 360, it will still give you 7 over 24 because the ratio here is the same. So I just want you to know what are the shorter ways of doing a certain question. So that will complete your question number 9. Okay, I will move on to your foolscap paper question. Let's move on to question 2. For each of the following circles, find the length of the minor arc AXB and the perimeter of the major sector OAYB. Now take note, they want the length of the minor arc, but they want the perimeter of the major sector. Read carefully, okay? Alright, let's take a look at 2B. Alright, length of the minor arc is just 112 over 360 times this. You'll get the answer, straightforward. Okay, now perimeter of major sector OAYB. Now take note that the angle subtended here is actually 248. We get 360 minus 112, we get 248. So this particular part will give us the length of the major arc here. Okay, I must plus 16 because they want the perimeter of this sector. So finally, I will get to 3 significant figure 101 cm. Okay, now we are just applying the formula, but be very careful when you read the question whether they want the minor or the major, whether they are giving you the diameter or the radius. These are the two things that you must take note of. Okay, next we move on to 2C. Now for 2C, they want to find the length of the minor arc AXB. So in this case here, we have to find out this angle first, which is 145. We apply the formula, we get 44.5. Now the perimeter of the major sector will be the length of the major arc plus 17.6 plus 17.6. You will get a 101 cm. Note that we are just applying the formula, but you have to apply it carefully. Okay, next I'm moving on to question number 3. Find the radius of each of the following circles. Now if you look at question number 3, it tells you that the length of the minor arc is 26.53 cm and this angle is 95. So 95 over 360 times 2 pi r will give me 26.53 because this is the length of the arc. Okay, I leave the r here, I shift everything over, I give the answer to 3 significant figure, I will get the radius as 16.0 cm. Can you see that in this question here, we are using the formula to find the radius of the circle. Okay, next we are going on to question 4. The radius of a circle is 14 meters. Find the angle at the center of the circle subtended by an arc of length 84.6 meters. The question says giving your answers correct to the nearest degree. Okay, now in this case here, you need to sketch a diagram. The radius is 14 meters and the length of the arc is 84.6. We let the angle subtended be theta. That means the length of this arc here will be 84.6. Okay, now we apply the length of arc formula is this. Okay, we plug in 84.6. We leave this here, we bring everything over, we have this. And finally, if you want to find theta, we multiply by 360 degrees. We will get the answer as 346 degrees. Now this particular question want the answer to be corrected to the nearest degree. If it is not stated, then all answers in degree must be given to 1 decimal place. Okay, so that is your question 4D. Alright, next we are moving on to the next one, that is question number 6. Now question number 6 is quite a simple question, but you have to read the question carefully here. It says that a piece of wire 32 cm long is bent to form a sector of a circle of radius 6 cm. Find the angle subtended by the wire at the center of the circle. Now, we know that this whole thing is 32, and they tell you that the radius of the sector is actually 6 cm. Okay, that means the radius of the circle is 6 cm. Now, if this 2 is 6, it makes up 12. So it leaves that the length of the arc is actually 20. This is the part that you must know before you can solve this question. So we will apply the formula. Length of arc is this. We substitute in 20. We substitute all the relevant numbers here. Then we find out what is x. So the angle subtended at the center is actually 191.0 degrees. Okay, 191.0 degrees. So it's important that you know how the sector looks like and what numbers to plug in order to get the answer. So that is your question number 6. Okay, we are moving on to question 7b. 7b says that find the radius of each of the following circles. Okay, now let's take a look. Now they tell you this question it looks simple, but if you make a mistake, then you cannot get the answer at all. Okay, the question says that the perimeter of the major sector is 278.1 cm. Okay, now major sector is this one. The perimeter will be this arc plus these two radius. Okay, now this is 44 degrees. We have to find the angle over the other side, which is 316 degrees. So 316 over 360 times 2 pi r plus 2r will give me 278.1. Note that this is the perimeter, not the length of the major arc. Okay, have to be careful here. Now, how do I get from here to here? Can you see that r is a common factor? I take it out. I put the things inside. I take out the common factor. It will be this. So if r stays here, it will be this divided by this whole thing. I key in the calculator. I will get a 37.0 cm. Okay, so bear in mind that in this question, the perimeter of major sector is given, not the length of the major arc. So you have to read the question carefully. Okay, now next, question 8. The figure shows two sectors, OAB and OPQ, with O as the common center. The lengths of OA and OQ are 8 cm and 17 cm respectively. Given the angle AOB and angle POQ is 60 degrees, find the perimeter of the shaded region, giving your answer in the form A plus B pi, where A and B are rational numbers. Rational numbers means that they can be put in the form of fractions. Okay, now everybody knows that this whole thing is 17 and this is 8. So it follows that this is 17 and this is 8. So this will left with a 9. So the perimeter of the shaded region is actually 9 plus 9. That means 9 times 2, okay, plus 60 over 360 times 2 pi r. This small arc here, 8 as the radius. And this larger arc here, 60 over 360 times 2 pi r. The r is 17. So we find out all of it in terms of pi. And we can get this answer here, 18 plus 25 over 3 pi. Now, some people will ask me, is 18 a rational number? The answer is yes. 18 is a rational number because 18 is actually 18 over 1. Okay, note that a rational number means that it can be written as a form of a fraction. Alright, so that will be your question number 9. Next, we are going on to question number 10. Question number 10 is very similar to the example question, okay, but I will give you some alternative methods to solve it. Alright, let's look at question number 10. It says that, okay, in the figure, O is the center of a circle of radius 7.5 cm. The points A and B lie on the circumference of the circle, and OBP, alright, is a straight line. Given that PA is 14 cm and OA is perpendicular to AP, find angle POA. Now, angle POA is this angle here. Okay, in order to find this angle, I look at this triangle, I use tangent. So tangent POA is this. I will get the answer as 61.8 degrees. Okay, 61.8 degrees. Now next, they want us to find the parameter of the shaded region PBA. So PBA, the shaded region. Alright, now I need to find the length of OP. Now of course you can use sine, cosine, tangent to find the length of OP. It's okay. Alright, but you have to use the answer that is found here. Okay, now note that I always try to use the information that's given in the question. So instead of using sine, cosine, tangent, I will use Pythagoras theorem to find OP. So I'll apply Pythagoras theorem. I will get OP as 15.882. That means this whole length here is 15.882. Alright, so the parameter of the shaded region will be the length of this arc here, which is this over this times 2 pi r plus 14, which is here, then plus this length. How do we get the length PB? This is the length PB. You take OP minus OB. Alright, so 15.882 minus 7.5, you get this, and the final answer will be 30.5 cm. 30.5 cm. Okay, so that is how we get the answer. Alright, next, for question number 12. The figures show a sector, okay, of a circle with center O and radius 13 cm. Given that the length of the chord AB is 22 cm, show the angle AOB is approximately 115.6 degrees and find the parameter of the shaded region. Now, I want you to take note that this is 13 cm, this will also be 13 cm. This is an isosceles triangle. So if this whole thing is 22, I will have this length as 11 and this length as 11. Now, this is a right angle triangle. I will use sine theta to find half of the angle, which is this, and angle AOB is just this value times 2. I will say that we can find out that it's 115.6 degrees. Okay, so that's how we show the angle AOB is 115.6 degrees. Now, in the event that you cannot get or you cannot show the 115.6 degrees, you still can use the 115.6 degrees in part 2 to get the part 2 answer. It is allowed. Okay, so please don't just, you cannot show part 1, you don't do part 2. You can apply the 115.6 degrees in part 2. Okay, now next, I'm going to show you part 2. Part 2 says parameter of the shaded region. So we take 22, I must find the length of this arc. So I take this value with the working. I cannot take this one because this is rounded off. I take the working here, I times 2 pi r, I will get 48.2 cm. Okay, 48.2 cm. So that is how we do question number 12. But I want to give you an alternative method to get this angle 115.6 degrees. Now I want you to look at this particular triangle. Okay, now I want to find this angle. I know this is 22, I know this side, I know this side. I can also use cosine rule actually. Okay, alternative method for part 1. I can also use cosine rule because I'm finding the unknown angle. Okay, now if I use cosine rule, I will have 22 square equals to 13 square plus 13 square minus 2 13 13 cosine angle AOB. I do the necessary bringing over and so on, just like in the previous chapter. Okay, then I can find angle AOB as 115.6 degrees. So that is another way. Now in the exam, if you use any way that is logical, the marks will be given to you. But make sure you understand your concepts before you apply it. Okay, now in conclusion for this particular chapter, okay, you must make sure the question is asking you for the minor or major arc, or they are giving you the parameter, or they are giving you the diameter or the radius. All these have to be done carefully in order to get the answers correct in the questions. If you misread the question, okay, then that will be the end, because all the answers there will be wrong because you have read the question wrongly. For example, if the radius is 15 cm, and you read it as the diameter is 15 cm. It just means a different thing altogether. Okay, so class, be very careful when you apply the formula. Okay, and this section is actually a very simple section, just that all of you have to be careful with the information that is given to you and apply it wisely. Okay, so that's all for this part. Thank you, class.